Welcome to the fourth video in the Raspberry Pi tutorial series. In this tutorial we will look at networking. We will discuss how the Raspberry Pi connects to a network and the networking tools which are available in the Linux operating system. We will firstly look at how we connect the Raspberry Pi to a network for internet access and methods for connecting remotely. RJ45 connection. The Raspberry Pi has the RJ45 socket which can be connected directly to network-capable devices via an Ethernet cable. For example, when it is connected to a home broadband router, the router will issue an IP address automatically using DHCP. The Raspberry Pi can then connect directly to the Internet. Wi-Fi connection. A Wi-Fi dongle can be connected to the USB port on the Raspberry Pi in order to connect to Wi-Fi networks. In order to connect to a Wi-Fi router we need to adjust the network interfaces file and add in the wireless SSID and passkey. We do this by opening the terminal window and typing sudo nano etc network interfaces. This will open the network interfaces configuration file. The last two lines of the file need to be changed to the SSID and passkey of the Wi-Fi router you wish to connect with. Once this is completed we reboot and the Raspberry Pi connects with the associated Wi-Fi router. Secure shell connection. The Raspberry Pi can be run without a keyboard, mouse or monitor by connecting through Secure Shell on port 22. This is known as running in headless mode. Port 22 is open by default and using a SSH client such as PuTTY, a remote connection can be established by entering the IP address and port 22. To connect to the Raspberry Pi from any device on the Internet we need to firstly find the router's external IP address and enable port forwarding to the Raspberry Pi's internal IP address using the SSH service. Connection can be established again using the SSH client and entering the external IP in port 22. SSH clients are available on many platforms so this connection can be made through Android and Apple mobile devices. Network diagnostics. We will now discuss the various network diagnostic tools available on the Linux system. Linux uses the following abbreviations for the available network interfaces. F0 is the Ethernet interface. WLAN 0 is the wireless network interface. LO is the loopback interface. If there are additional Ethernet or wireless interfaces available they will be referred to as F1, WLAN 1 and so on. We can view information on these interfaces by typing the following command: Ifconfig. This command shows the IP address, MAC address and subnet mask of each interface. It will also display packet information. We can specify which interface we want to view by typing ifconfig followed by the interface name. For example, ifconfig WLAN 0 will show all details for the wireless interface. The same command can be used for the Ethernet and loopback interfaces by replacing WLAN 0 with F0 or LO. The network interfaces can be enabled or disabled using the IF-up and IF-down commands followed by the interface name. For example, sudo if-up F0 to enable the interface, or sudo if-down F0 to disable the interface. To set a temporary IP address to an interface we can use the following command: sudo ifconfig F0 192.168.0.5 netmask 255.255.255.0. We can use ifconfig F0 to see that the IP address has been assigned. This IP address will stay on the interface until a reboot is performed. To assist further with diagnostics, a network interface can be put into promiscuous mode. We can do this by typing the following command: sudo ifconfig F0 promisc. Checking the configuration for F0 shows the interface is now in promiscuous mode. In promiscuous mode the interface will receive all network packets which can be analyzed to assist with diagnostics. The host name of a Linux system can be found by typing hostname. This command returns the host name. To change the host name, it is necessary to edit the host name file in the etc directory. To do this, we type sudo nano etc hostname. This will open the hostname file. The current entry can be amended as required. When the system is rebooted, the hostname will be updated. The ping command is used for testing connectivity of a remote system. Typing ping, then the hostname or IP address of a system will send an ICMP packet to the destination address continuously until Ctrl and D are pressed to exit. To prevent the continuous packets being sent, we can use various switches to adjust this. The following examples will display the ping command's usage. Ping -C6, -S, 1000, 192.168.0.1. The -C switch is used to set the number of packets to be sent to the destination address. The -S switch specifies the size of the packet in bytes. Ping -A, 192.168.0.1. Using the -A switch will provide an audible beep when the destination address is reachable. Sudo ping -F 192.168.0.1. Using the -F switch will flood the destination address with data packets. The command needs to be run as root. A full stop is shown when a packet is sent and a backspace used when a packet is received. Caution should be used with the -F command, as this may cause the remote system to go offline. Typing man, ping, will show the built-in manual and information on all the available switches and uses. Trace route is used to display the network path to a destination IP address. To use the command, we type trace route followed by the IP address or host name. We will trace the network path to google.com and view the result. To use the command, we type trace route www.google.com. This displays the network route showing the full DNS name and IP address of each router encountered from the source system to the destination system. To display only the IP addresses of the route, we add the -N switch as shown. Trace route www.google.com-N. To view the manual for the trace route command, we type man trace route. The route command can be used to show or manipulate the IP routing table. It is used to set up static routes to specified hosts or networks via an interface. To view current routing table entries, we type route. The manual for this command can be accessed by typing man route. The ARP command can be used to find the MAC address of a remote system. We can see the entry for a remote system by typing ARP followed by the IP address of the remote system. The command will return the remote system's MAC address if it is in the current ARP table. To use the command, we type ARP 192.168.0.1. The manual is available by typing man ARP. The Netstat command displays network-related information. We can view TCP and UDP ports and their connection state. The following examples show the command's usage. Netstat -A shows all listening and non-listening ports. This will show all TCP, UDP and Unix ports on the system. To view a list of only TCP ports, we use the following command, netstat -AT. To view a list of only UDP ports, we use netstat -A, U. We can view all listening ports on the system. We use the following command, netstat -L. To view only the TCP ports which are listening, we use the following command, netstat -LT. To view only the UDP ports which are listening, we use the following command, netstat -L, U. We can view only the Unix ports on the system by typing netstat -LX. To view the manual for this command, we type man netstat. There are two more commands we will discuss which assist with network diagnostics. The commands are nslookup and dig. These commands are not available by default, so they need to be installed. To install and make the commands available, we type sudo apt-get, install, DNS utils. Once installed, the commands will be available. NSLOOKUP is a tool which is used for querying the domain name system to obtain the domain name or IP address mapping or other DNS record. In the following examples we will use the command to find the A record, which is the IP address, the MX record, which is the mail exchange, the NS record, which is the name server, and SOA record, which is the state of authority record. All this information can be retrieved using NSLOOKUP followed by the type equals any switch. We will look at all the DNS records for google.com by typing the following: NSLOOKUP -type equals any www.google.com. This command will display all the available DNS records for the domain. The NSLOOKUP command can be used to perform a reverse DNS lookup. For example, if we know the IP address of a server and want to find the DNS name that it belongs to, we use NSLOOKUP followed by the IP address. The manual is available for this command by typing man, NSLOOKUP. The dig command will produce similar results. We will use the command to look at DNS records for google.com. To do this we type dig www.google.com. The command returns all DNS records for this domain. We can also use dig for reverse lookup by using the -x switch. To do this we type dig -x 173.194.34.144. This will return the domain name which is associated to this IP address. The manual is available by typing man, dig. It is possible to view web pages in the terminal window using a text-based browser called Links. To install Links we type sudo apt-get install Links. Once installed we can view web pages by typing links followed by the web address. For example, we can view google.com by typing links www.google.com. We hope you enjoyed the fourth video in the Raspberry Pi series. Please feel free to ask questions and leave comments, and please subscribe to the channel.